measuring the mass of a solid body by the double pan balance. Here we have a scale pan on the left and another scale pan on the right, and this is the pointer of the instrument. You can see it right at the middle of this instrument here. So this shows that the pans have the same weight. The weight here is equal to the weight on the right pan. The pans, they balance horizontally. Here we have a bus of mass, so we're going to use these masses to determine the masses of these unknown pieces of sugars on this side. So I'm going to start with this. I'm going to take 2 pieces of sugar cube and place it here. Now you can see that the palm on the left hits to the left while the pointer hits away from the middle, and this shows that the masses are no longer equal because the beam is no longer balancing horizontally. So I'll take a mass from here and place it here. So this is a 10-gram mass. Let's see what happens, and you can see that the balance remains on the left hand side, meaning that the mass of these sugar cubes here is greater than the mass, the 10-gram mass placed on the right pan. So I'll take another mass. Let me take 5 grams and place it here. So on placing the 5-gram mass, and see that the scale pan tilts to the right now and the pointer tilting to the right. So it is still not balanced, meaning that the weight of this sugar now, or the mass of the sugar rather, is less than 15 grams. So what I'm going to do, I'm going to take away the 5-gram mass. So on taking the 5-gram mass, you see that the scale pan on the left tilts back to the left. So I'll look for a smaller mass. Let me try 2-gram mass and place it on this. So on placing this on, let's swap. Okay, now you can see that the pointer balances at the center of the instrument, and the 2 pans balance horizontally. So it therefore means that the mass of cube here is equal to the masses that we are placed here. So the total mass here is 10 plus 2, that's 12 grams. So since these cubes are similar, it means that one of the sugar cube is 6 grams. We can confirm that by typing 6 here and see what happens. So it's correct. So that is how to use this instrument to determine the mass of an object. Next, we are going to look at how to measure the mass of a liquid using the electronic balance. So this is my electronic balance. Here we have a beaker and a container of water. The electronic balance is set off. Here we have the on button and the tab button. And what the tab button does is that it can set the measuring instrument to 00 even when a mass is placed on it. So let me put this on. The reading on this is 0.0 gram. So let me place the beaker on top of this. On placing the beaker, you can see that the mass of the beaker is 49.1 gram. So I'm going to tag this, meaning that I'm going to return the mass reading here to 0. So I'll just press the tab button, so it goes back to 0.0 gram. So let me take my container of water and see what happens. So I'll add water. You can see that the mass of the water increases. So the mass of water inside this beaker, 10.3 grams. Now add more water. So when I add more water, you get this, okay, I get 22.5 grams. So the mass of water here is 22.5 grams. Now this is how to use the electronic balance to determine the mass of a liquid. Here we are looking at how to make use of the spring balance. This is a spring balance, and the maximum weight that the spring balance can carry is 2 Newton. Then we have some masses here that we can place here to determine the mass. So here what I'm going to do, we are taking the weight of the object on Earth. So I'm going to take the weight of the object on Earth, on the moon, and in mass. So let's start with this. This is a 200 gram mass. So I'll place it on this hook of the spring balance. Now you can see that the spring balance weighs 1.96 Newton. Okay, so let me remove that again. Now before I move on, I want you to know that a spring balance makes use of the principle Hooke's laws of elasticity. Makes use of Hooke's law of elasticity because the load or force that is attached to this spring is proportional to the extension made by the spring. So let's try for another mass, 100 gram. So you can see that the spring extends to 0.98. So this is the pointer of the spring. So use the pointer to read from this horizontal point, and that gives us 0.98. So it's a little bit short of 1 Newton. So a 100 gram mass weighs 0.98 Newton on Earth. So let's try it for this, for 50 gram. So again, you can read from this pointer here horizontally. So this reads 0.49 Newton. That is, so we can try the mass in the moon, and the weight rather in the moon. So let's see. So you see that it weighs way less than it is on Earth. So a 200 gram mass weighs 0.32 Newton in the moon, while it weighs 1.96 Newton on Earth. So you can see the difference. This is because the Earth has a higher acceleration due to gravity. Let's check the mass. We can also check that same weight in mass. So it is 0.74 Newton. So you see that it weighs 200 Newton mass. Sorry, 200 gram mass weighs more on Earth than in mass than before in measuring the volume of a liquid. Here, we want to look at how to measure the volume of a liquid. Here I have a measuring cylinder graduated in millimeter, and the maximum volume of water or liquid that this measuring cylinder can take is 100 millimeter. So what I'm going to do is to take the water can and add the water to this. Here, I want to show you how to take readings on this. So this is the correct way of taking reading. So here you can see that this is the eye is at the 0 millimeter and it's at the meniscus. This is the meniscus, this concave meniscus. So you read from the concave, below the concave of the meniscus, with your eyes fixed horizontally to this point here. That is how you take reading from this cylinder. So you look at this there, you can see that the position is like this. When your eye is at this level and you want to take reading from here, you get error due to what? Parallax. So let's add water to this and see what we'll get. So I add water. So this is 17 millimeter. Let me take it to 20 millimeter so that you can see how it records it. So this 21 point, okay, it's beyond that. Now that's 20. Okay, let me take it to 30. Okay, 20. Okay, I think 25 millimeter is okay. So you can see the right way of taking it. When you take it from this point here, it's wrong. You get error due to parallax. When you take it from this point this way, you get error due to parallax. Again, when you take it from this point here, you get error due to parallax. So you have to take it horizontally from the bottom of the meniscus to give us 25.0 millimeter. You can add more water so that we can take other readings. So this is 40 millimeters. So you can see it here from the meniscus underneath here. So let us look at volume measurement from other liquids. So this is a measuring cylinder, like we said. So can we determine the volume of this liquid here? Yes, we can. From the meniscus, I'm going to, this is 60, 70. So you can see the division is 1, 2, 3, 4, 5. So it is, each of this division is 2. So I'm going to have 70, 72, 74, 76. So this is 76 millimeter. Let's submit that and see it is correct. So that is how to read. Now to take reading from this, you can see that this is 100 and this is 150. So it means that the gap between them is 50. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So dividing 50 by 10 is going to give us 5. So each of them is going to be 5 each. So this is 150, 155, and 160. So this is going to be 160. Submit that. It is correct. So you read from the meniscus. So these are pipettes. These two here are pipettes. So you can take volume from this. So you can see the division. This is 5, 6. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of them is 0.1. So if I want to take the reading for this, is going to be 6.1, 6.2. So let's check for that. It's also correct. So we'll take from this, you see the meniscus here. So this is, now you are reading this downward. So the division is 10 also. So this is 7, 7.1, 0.2, 0.3, 0.4, so this is 7.4. Measuring the volume of a solid. So you're going to look at how to measure the volume of an irregular solid. So here I have a measuring cylinder. I have a measuring cylinder here, and I have a mass of 100 grams. Now I want to determine the volume of this. How do I determine that? I'll place this mass, I'll place it inside this measuring cylinder containing water. Here the volume of water is 80 cm3. So what I'll just do, I'll note the difference between the two volumes. That is what we are going to do. So I'm going to place the mass inside the measuring cylinder. So let's take this. So I'll take this and place it inside this. So we're going to note the rise in volume of water. So it was 80 before. Now the volume rises to 90, 91, 92. So 92 minus 80 is definitely 12. So we'll just type this here and submit 12 and check whether we are correct. So it's very correct. So that is how to get the volume of an irregular solid.